So welcome back to Bal Vigyan Bharati with Vilas Sarkar, and here we are discussing on time and work problem. Till now we have reached problem number 36. The next will be 37. A can do a certain work in same time. A can do a certain work in the same time in which B and C together, in which B and C together can do it. If A and B together could, if A and B together could do it, in 20 days, and C alone in 60 days, then B alone could do it in how many days? In how many days? Okay. So let us understand. A can do a certain work in the same time in which B and C. So the efficiency of B plus efficiency of C together with the efficiency of A, because A can do a certain work in same time in which B and C together. So if their efficiency together is same as A, then only they can do the same job in same time. Second is A and B together could do it in 20 days. So the efficiency of A, that is efficiency of B, is 1 by 20 efficiency, and C alone can do, alone in 60 days. So efficiency of C is 1 upon 60. Okay, so this is enough, and then B alone could do it in how many days? So B efficiency is needed. Now this all together is how much? Efficiency of A plus efficiency of B plus efficiency of C all together. This is this plus this, that means is equal to 60. This is 3 plus 1, that is equal to 1 by 15. Okay, so all together this is 1. Now again this is equal to this, so this is equal to this equal to, again I can say efficiency A. So this, from there you can say the 2 of efficiency of A is equal to 1 upon 15, because this total is equal to A. Here I can put the value of efficiency A. So efficiency of A is equal to how much? 1 by 30. So is there any relation with B? Yes. So from there efficiency of B is how much? 1 upon 20 minus 1 upon 30. That means 1 upon 60. So B can do how many days? This will be 60 days. Okay, efficiency this means 60 days. So we move on to the problem number 38. Can delay, we can A can finish job in 18 days, B can do the same job in half of his time. A together, what part of the same work they can finish in a day? It's going to be very easy. You can do a piece of work in 30 days, he works for 6 days, B finishes in 18 days, he can together. This is okay. This is also okay. Okay, I'll take this. When A, B and C are deployed for a task, deployed for a task A and B together do 70% of the work, and B and C together do 50% of the work, okay. Who is most efficient? Okay. So when A, B, C all together deployed for a task, A and B together can do how much work? 70% of the work. So the fraction of job they did is 70%. Together what? A and B. The job they did is 70%. That means 7 upon 10 fraction they did. Okay. So if 7 upon 10 fraction is they did, and they are working for, let's say all are working for D day. Okay. Now this efficiency is A, this efficiency is B, and C is taking efficiency of C. So their efficiency, for their case of this one, their efficiency into the day will be the part they are doing plus into day the part they are doing. So from there we can say that if D is taken common, efficiency of A plus efficiency of B is 7 upon 10 days, 10D. This is the equation 1. And second case, when B and C doing together, the job is being done by B and C together, they are doing 50%. The efficiency of B into number of days, because the day will be same, because all three are doing for the same. Within that, if I combine A's job and B's job, they are doing 70%. If I combine B's job and C's job, they are doing 50%. Okay, so but number of day they are working all together. So this is B and C into D, that is equal to half. So the efficiency of B plus efficiency of C, that is equal to 1 by 2D. Okay. So this is 7 by 2D, this is 1 by 2D. Now you have to find the value of each. Okay, and another equation, efficiency of A plus efficiency of B plus efficiency of C is 1 upon D, because all together working for D days will complete the complete job. This is the untold, but the third equation, you can say. This is second, this is third equation. Understood? So now what is their individual efficiency? Now this is N B plus C efficiency. Now A can be calculated from this. A can be calculated by what? 1 by D minus, if I deduct this one, minus 1 by 2d. So that means is equal to 1 by 2d. Efficiency of B, how will I calculate? C I calculate. A and B, from there if I deduct, is equal to C 1 by D minus 7 by 10D. So that is equal to how much? 10D, and this is equal to 7 minus 10 minus 3. This is the efficiency of C. So you can write here efficiency of A is 1 by 2D, efficiency is 3 by 10D. So the remaining is B. So B you can put anywhere. You will get 1 by 2D minus, if I deduct C, this is equal to 3 by 10D. So that is equal to how much? 10D will be there. 5 minus 2. This is 2 means 5 minus 3, that means 2. So 1 by 5D. 1 by 5D. Now you can compare. Out of this is equal to, if I put it in decimal, 1 by 5, that means equal to 0.2 by D. This is nothing but 0.3 by D, and this is equal to 0.5 by D. So the most efficiently who is having this value, higher the numerator. So efficiency A has the highest. The most efficient is A, is most efficient. Understand? So now I will move on to the problem number 39. Let me check any interesting sum is there not. Four men, 6 women can complete in 8 days, 3 men 10 days. In how many days will 10 men complete it? Is okay. P and Q can complete it 22 days only. P around 30 days, both of them working together 8 days and every day. These are some usual problem already discussed. 2 men, 3 men can do a piece of 8 days. 8 days, how many days? Okay. 2 pipes and we can fill a tank in it. Okay, let me take this. This is very lengthy problem, but still I will take this. A pipes, 2 pipes, 2 pipes A and B can fill a tank, in 24 hours, and 17 by 1 by 7 hours respectively. Okay, fine. Harihar opened the pipe A. Harihar opened the pipe A and B to fill an A and B to fill an empty tank. And sometimes later he closed the taps A and B, and sometime later he closed the taps A and B. When the tank was supposed to be full, when the tank was supposed to be full. After that, it was found that the tank was emptied in that the tank was emptied in 2.5 hours because an outlet pipe C connected to the tank was opened from the beginning. Connected to the tank was open from the beginning. Okay. If Harihar closed the pipe, closed the pipe instead closed the pipe C instead of closing pipes A and B, the remaining tank would have filled in how many hours? So fine. Now there is a tank. Let me put it in a form of you can say in a graphical representation. There are two pipes in, A and B. Filling C is getting out. Tank is filling with the pipe. Let's say I'm putting it from the top. Okay. Tank is filling by the two pipes A and B, and this C is somewhere at the bottom. Okay. Two pipes A and B can fill the tank. So in 24 hours. So when A and B together, they are filling in 24 hours. The tank filling is a complete 24. Oh, sorry, no. A and B individually can fill in 24 hours, and so the efficiency of A is how much? 1 by 24, and efficiency of B is equal to 1 upon 17, 1 by 7. So all total this how much? 7 7 is 49, 4 109 110, 7 upon 110. So this is the efficiency tank, and sometime later he closed the tap. Sometime later he closed the taps A and B when the tank was supposed to be full. So that means by assuming this together filling the tank, and he has estimated the time when the tank will fill. When the time at that time he closed both the tab. So it's together how much they are doing? 7 upon 110. So that is equal to 110. This is 5. No. 7 7 49 7. No. This is 120. 7 7 49 4 7 4 11 plus 1 119. This is 110. 120. This is 5 plus 7 12. So this will become 1 by 10. So all together they are filling 110. So they need 10 hours time. So A plus B together can fill in 10 hours. So after 10 hours he closed. So by that time, but C is open from the beginning, he doesn't know that. When he has stopped that, after that it was found that the tank was emptied in 2.5 hours. So what they have filled in 10 hours, that along with that time, the 10 hours they are filling, that time also C is opening. So C is taking 10 hours plus 2.5 hours after they are stopping. So all total C is taking 12.5 hours to empty the tank. So C's efficiency of C is how much? 1 upon 12.5. Understood? Now what they are saying, instead of closing the C at the time of AB, if AB not closed, instead of that C has closed after 10 hours. So what is the remaining, what is the time it will take AB to fill the remaining gap? So that means by assuming that after 10 hours it will fill, he has closed after 10 hours, by that time how much C has emptied with this efficiency in 10 hours, so I will rub it out because this is not needed. So now question is that after 10 hours C can empty how much? Efficiency of C into 10 hours. So this is equal to 1 by 12.5 into 10. So this much fraction C will empty. So if instead of closing A and B, C closed, so this much only the part that is needed to be filled after that. So A and B together. So this is the requirement now. What is the time? So time to fill by A and B after closing C will be this is the fraction of tank empty, and the efficiency of A and B together is 1 by 10. So with that efficiency, this fraction has to be filled in how much time? 12.5 divided by 1 by 10. So this is the this fraction, yes, fraction of time, this is the fraction remaining, and this is the efficiency. So efficiency of A plus B together, this is the fraction of time. So the time will take is equal to 10 hours efficiency 1 by 12.5, 10 hours this much emptied, yes, fine. So time will be how much? 1 by the fraction remaining 12.5 upon the efficiency 1 upon 10. So this will be 10 upon 12.5 into 10. So this much. So 10 into 10 by 12.5. This much hours it will take. So this is 100 upon 12.5 by this is the 8 hours. Okay. So A and B will fill after C is being closed. Instead of A, B, it will take 8 hours to fill the remaining time. So I will end up here. I will move on to the problem number 40 in the next video and onwards. Okay. So thank you for now. Good night.